Good morning, everyone, and welcome to our, should we say, morning session or before lunch session from Qualisys, where we will talk a little bit about engineering. But before we start, I would like to give you a slight idea about how we think time-wise. We'll do a short presentation of ourselves up here on stage. Then we go into some PowerPoints and discussions about industrial and engineering. We will show a little bit about underwater. We have Pedro from Poly here who will talk about what they do. And then we have a little bit of a demo with drones before we end the day. I would like to say that during this time, all of you on the streaming, please feel free to post any questions, because there will be people, putting up the hand for us, and we will try to answer those questions while they pop up. So if you have any questions, don't hesitate to write in the streaming, and we will try to answer those questions. Okay, who are we? Well, my name is Martin Skoger. I'm the from Qualisys responsible market person, taking care of Brazil and some other countries. Together with me is my colleague, Marcus.
Hi, I'm Marcus Johansson, and I'm working as a field application engineer. And I have been working here in Brazil for quite many years, and also Asia is my areas. So I know quite a few of the facilities here already. So I hope I can meet you in person soon again.
Hello, my name is Jean-Marc. I work in the animation and entertainment department. So today I'll have the pleasure of showing you some interaction between QTM and some game engines, Unity and Unreal Engine. So looking forward to it.
Bom dia, sou o Orlando Orlandi, parceiro, representante exclusivo da Qualisys aqui no Brasil. Sou diretor, gerente técnico de operacional da Carci, cuidando toda da parte de treinamento, instalação aqui no Brasil, da parte industrial, biomecânica e animação também. Okay.
Okay, that gave you a little bit of who we are, at least. So let's see if we can start with the company itself. I will give you a short idea about Qualisys. We are actually based in Sweden. It's a pure Swedish company based in Gothenburg, heart of Sweden, you can say, on the west coast, where we are about 40 to 50 people employed. But we work, of course, worldwide and have our office in US, in Chicago, and we have an office in China, in Shanghai, and Singapore. So we split up the market. But Brazil is handled from the European side. That is actually due to the fact of the Portuguese and also a lot of connections into Europe. So that's a very common way of doing it. So that is how we handle the world globally. And down here we are represented by Carci, who is our partner. I used to show this picture which gives an idea about some references, because there's a wide spectrum we are working with. Everything from universities in different applications to car manufacturers with autonomous driving. It's into sports, it's into, like I have on the screen, ABB, just using our cameras and taking the signal into their own system to see different movements. Later today, Marcus will talk a little bit about those applications, so you will get a better idea. But at least it gives a view of the wide and big variety that we are into. So, well, every company has its mission, and of course our mission is to be a preferred partner, and that is what we are looking for. Very often we work close to our customers in their interactions and also developments in what they want to do. But preferred partner is our mission in this. If we go further into the company and structure and how we work, we have actually full control in-house, meaning that we have the hardware development with our own staff. We have also the software development, And then we have research and commercial part, of course, where I'm coming into the picture in the end. And we divide our business into 5 segments, you can say, but in reality we talk about life science, entertainment, and engineering. So biomechanical and sports and animal goes into the life science, as you can see on the screen, while you have a separate industrial engineering part, which could be marine, it could be anything with drones, or anything actually that you would like to see. And then we had, as Jean-Marc said here before, an entertainment VR part, which is separate as well. So that is how we are structured within the company. I hope that gives at least a little bit of a glimpse in how it works. But we have a full control and we have a full production in-house of our systems. So with that said, I would like to hand over to Orlando, talking a little bit more about Carci and what they're doing. So feel free.
Thank you.
Thanks.
Thank you, Martin.
My pleasure.
Okay. You can show. Do you need the... Okay. No, don't. Don't worry. Bom, na verdade, a Carci, ela atua na área da fabricação, distribuição de equipamentos, na área de fisioterapia e reabilitação. Mas devido a ter um corpo técnico e a representação de outros equipamentos que envolve outros produtos, a gente acaba entrando na área industrial. A minha formação, eu sou engenheiro, né? Engenheiro mecânico. Então, a gente acaba atendendo outras demandas aqui no Brasil. A Carci tem a base em cima de ética, respeito, profissionalismo e conhecimento técnico. Então, todos os nossos equipamentos a gente consegue dar manutenção, dar suporte técnico a todos no mercado brasileiro. E com isso, a gente, com esses equipamentos de alta tecnologia, a gente dá maior credibilidade para o cliente utilizar essas ferramentas. Então, nós temos, provavelmente, a gente tem cerca de 80 funcionários na nossa empresa. A Carci, além de importar equipamentos, né, distribuir, nós também fabricamos e exportamos equipamentos para todo o mundo, cerca de 40 países, dentro da Europa, Ásia, América e África. Isso interfere diretamente no intercâmbio de novas tecnologias, então a gente sempre traz coisa nova para o mercado brasileiro. Basicamente, a linha de produto da Carci, ela tem a linha é a mais completa do Brasil, onde a gente entra na parte de eletroterapia, que são as ondas curtas, estimuladores, laser. Temos a parte de hidroterapia de aço inox, equipamentos de reabilitação, termoterapia, advance e outros equipamentos para mobilização. Algumas marcas que nós trabalhamos, né? Vou falar de trás para frente. A Delcis, ela trabalha com eletromiógrafo, são potenciais evocados da parte do músculo esquelético, que é a atividade muscular. Plataforma de força, que é a Bertex, são células de carga, que nós atuamos também. TechScan, são sensores de pressão, que além da parte de utilizar na pressão plantar, ela pode ser usada em outras áreas, na área industrial, até mesmo na fabricação de pneus. O Cyclus é um ergômetro de potência. Biodex, basicamente, tem equipamentos de isocinética, uma parte, um dinamômetro isocinético para avaliação músculo-esquelética de atletas, ou na parte de reabilitação. E a Qualisys, que entra em diversos, um sistema aberto, né, que entra tanto na parte de biomecânica, medicina esportiva, laboratórios de marcha, mas também entra por exemplo, na área industrial, com tanques da área naval, mensurações de cabos e outras aplicações que possam ser utilizadas com análise 3D. A Carci, ela tem no seu corpo o presidente, o senhor Orlando de Carvalho, que é meu pai. Ela foi fundada em 1966 pelo meu avô, Ivo de Carvalho, e eu hoje estou na frente da direção da empresa como a terceira geração para desenvolver. Basicamente, a gente leva ao consumidor, ao cliente final, independente de que área que ele esteja, a melhor qualidade, não só de vida, mas de potencialização dentro da área da indústria também, a melhor qualidade de tecnologia. Ok, Martin. Yes, it's done. It's done. Yes, it's done. It's okay. We can go forward to another. Agora o Marcos vai comentar da parte da apresentação da parte de engenharia. Apenas uma breve introdução. It's yours. Yes.
Yes, I have some information regarding our engineering products. So we have a short presentation here and also some movies that describe some of our application here. So this is what we call our end products. And we are working in quite many different fields. So our product is really flexible. So I mean, it's no limitation what you can do with this kind of products. So here is a list of the things that we actually have customers in these areas already. And I mean, I will not go into all the different areas that we are in today, but the key feature here with our system is that we are able to track six-stop body in big volumes and also small volumes with very high accuracy. We can stream the data in real time for closed control loops, and we can also use the system both indoors and outdoors. We also have a possibility to go underwater with the special cameras, and we can also combine underwater with normal cameras. Our system is quite often used as a ground truth system when they want to evaluate other kind of measurement systems. One big areas for us is the marine applications. And in the marine field, we have the possibility to measure both above water and underwater. We can also combine those two systems with the twin system. So you can actually measure an object that moves in between air and water. And we can, of course, calibrate the system together. So you can get all the data into one file. Martin? Yes. It's nothing happening when I press here. Yeah, could you just, this pointer is not working? No? We just have a technical issue here with the presentation, so hopefully we solve it soon here. No, I want to have the next one. Yeah. Excuse us for a second.
Só repassando, né, o que o Marcos colocou. Uma das principais aplicações que nós temos é a parte marinha, né, naval, onde tem alta precisão dentro de sistema de coletas de dados 3D, ou 6 graus de liberdade em tempo real, tanto fora da água quanto submerso, e os dois dados sincronizados, né, dentro e fora d'água. Isso é uma vantagem, porque dentro de laboratórios, até mesmo para aplicações marinhas, dentro de plataformas ou sistemas de fabricação, o Pedro pode até me corrigir se eu estiver errado. Isso é fundamental para a parte de segurança, né, dentro de a fabricação e controle dos quem tiver a bordo, né? Ok, Marcos.
Yeah, hopefully we have better luck with the PowerPoint presentation here now.
Okay.
Yep, we have a few different kind of setup that I want to go through in the marine case. First of all, we have a towing tank. It's quite common. And what we can do is, normally you have quite a long basin. It can be a couple of 100 meters. And to save the amount of cameras, we can actually mount our cameras directly on the carriage and follow the object. The other kind of setup is the ocean basin. And the ocean basin is like quite often free running models or anchored models. And in those kind of setups, you want to cover the whole volume with good accuracy. And we have a possibility to actually do that, to cover the whole ocean basins with quite a few cameras. We also have what we call the fixed camera calibration. And it's another way to also cover the ocean basins. But with this setup, you save a lot of time with the calibration. You don't need to go through the whole volume with the wand. And you can also get much higher absolute accuracy in the volume. And the last part, we also have the underwater. So we can mount camera under the water, and they can stay there for a month without being taken up. What kind of technique do we have to help out with your kind of measurements? What we have is contactless object tracking of 6 degrees of freedom. That means we use these optical cameras, so we don't need to have any wires between the object that we measure on. We can also stream the data in real time with very low latency. And we have really good accuracy. And it's like in plus minus a couple of millimeters, even in the big volumes here. And we can also detect very small changes. The resolution of our system is in sub-millimeter range. To be able to do that in these huge areas, we have both active and passive marker. And the good thing with the passive marker are that we are very lightweight. And with passive marker, we can measure up to 30-meter distance. But in huge basins, we need to go to the active marker. And with the active marker, we can reach over 100 meters without any problem. So here we will show a video. Martin? Yeah, this is a typical setup for a smaller towing tank where we're using our system. So here you can see our software, and you will see here later the object, the floating object. And here we're using the small passive marker that is very light-weighted. And here is another with the underwater tracking. And here you can see how it looks in our software. You can track multiple objects. And here is a file with the closed control loop. We're using our system to control the vessel here. Okay, Martin, you can take the next slide. Okay. Yep, please. Is it okay? Okay, we take the next one.
Underwater gliders, they are one type of autonomous underwater vehicles. They don't have propellers outside. They work based on change of buoyancy for long endurance operation. They can go 6 months with one battery charge. We use the diving well to install our underwater motion capture system. It is built of 8 infrared cameras. It gives us millimeter accuracy of tracking.
Yeah. Okay, here is another project that is done in Norway, marine tank. And this is a floating, you can see it will be a floating bridge that is done with a lot of floating devices here. So you can see each one is a rigid body, and on the right side you can see how it looks in our software. So it's a lot of small, light-weighted marker here. This we have already seen. We skip that. Here is another application. It's done made in Denmark. We're looking at the fishing net. So we see how the current is floating through the fishing net. So we have a lot of marker here under the water. This is a really old application. I think it's done like 15 years back. So this is the first version of our underwater cameras that is used here. So we have been present in this market for quite a long time. Yep, this is another application. It's made in US, in Maryland. It's also underwater, and they are a research institute. And here you can see the video files from each camera that is mounted underwater.
How many cameras they are?
Here we have 12 cameras.
12?
Yeah.
Okay.
And here you can see the object moving around in our software, tracking it. And we also have a drone tracking. Yeah, you can start, Martin.
It's never been easier to get drones working and flying at this point. Whether the world's ready for it or not, companies are going to start trying to do things with drones.
This facility is called M-Air. It's the netted flight facility that allows us to do all kinds of experiments with flying objects that can't escape. Our goal with the Qualisys motion capture was to have coverage of the entire facility, or at least as much of it as possible, to allow the vehicles to fly with continuous tracking. In aerospace engineering, we study a variety of things ranging from vehicle design and analysis of the structure to control. And control in the large sense involves perception, decision-making, and acting. All of these have to be done in real time in flight because it can be less than a second before a drone crashes if it makes a poor decision. Any facility that provides comprehensive testing for flight or ground-based robotic systems needs to have truth data. Qualisys can provide that data, and then each user can decide what they want to do with it, either in real time or later after the test concludes. The quality and reliability of the motion capture system are outstanding.
I believe it's down to like a millimeter of accuracy on where the vehicle is, which is not attainable through really any other means. Having that kind of position feedback is invaluable.
Qualisys had the longest proven outdoor option, which had a big influence on our decision.
We look at the weather as a real feature, not a bug here. It had to be able to run in the snow and the rain, ice events.
As long as my hands are warm, I can use the Qualisys system out here.
I think a lot of people who are developing facilities for flight vehicles recognize the need to have a high-quality motion capture system.
Using the information from the Qualisys system, we can automate these vehicles. You take people out of harm's way and you get the job done faster and more efficiently than you could with a person. Seen this in search and rescue with ski patrol, railroad inspections, wind turbine inspections, different photography applications.
We like to think that the University of Michigan is somewhat in the lead with both having a really nice professional facility constructed and to completely equip it with motion capture. We imagine others will follow us.
Yeah, this was an example when you can actually mount the camera outdoors permanently, and it's designed to actually work in that kind of environment. I think we can. This is another application.
I've been
with drones.
fascinated by all kinds of mechanisms, robots, electronics, for as long as I remember. And the physics, the engineering, the algorithms, they are very exciting, but my real passion is about how we experience these artifacts. My passion is design.
Interaction design is an interdisciplinary field that builds on computer science and product design. Our approach is what we call research through design, where we try to invent new things, and the process of building and then using these things is our research method for studying people and technology.
In product design and engineering, robots are like the most difficult thing you can work with. If you're building an industrial robot, you have to make sure that its behavior is precise and stable, so it's not only accurate to work with, but it's also safe to be around. Measuring and validating the quality of your robot is challenging. First of all, because it moves around in multiple dimensions, but also because sometimes you're not supposed to touch the robot. So in a scenario like this, a fast and accurate visual motion capture system like Qualisys is very helpful. This is the engineering use case. But it actually gets a bit more interesting than that. Recording the robot's movement and analyzing it are not the only things you can do with the Qualisys cameras. I'm very excited about the ability to track several different kinds of robots and to stream control signals to them in real time, so we can track robots and drones and props as well as the human body in the same calibrated coordinate system and build experiences with movement, controlling and, in a way, collaborating with these robots.
The experience of looking at images on a screen is very different from being in the same room with a physical, tangible thing that can move around you and respond to you. Our project is about the user experience of an interactive drone, and it's very different from any visualization you can put on a screen. You can move your body together with the drone, and you become very engaged since it's a real physical being in the room with you.
The larger drones, like the ones that photographers use, are really cool, but they produce a lot of noise and a lot of airflow from the propellers, and it's just plain dangerous if they crash into something or someone.
We have these tiny drones made by a Swedish company, BitCraze, that are quiet and safe and kind of cute.
The drawback of the tiny drone is that it doesn't have all the sensors and all the computers that you get loaded on its bigger brothers, so precise control of the flight path, detecting other objects, responding to human movements. For all of these purposes, we use Qualisys.
I'm interested in biosignals. Experiencing and playing with the connection from the body to another being, in this case the drone, can help us advance in how we sense and influence our own bodies and behavior. The prototype we're building now connects a wearable breathing sensor to the drone, and the drone becomes almost like a partner as you learn and practice breathing exercises.
One of the most interesting things about Qualisys, in my opinion, is that they have this extensive collection of open source software and resources for all kinds of platforms: Unity, Unreal, Python, the robot operating system ROS. Over the last few years of working with Qualisys, I've not only utilized but also contributed to these. A couple of years ago, I actually met another researcher who lives on the other side of the world in Australia. We exchanged messages on the Qualisys open source platform. He had the same hardware and the software, so we started collaborating, and we actually became really good friends. We published a lot of research papers together too.
Uniting the physical and digital worlds is the holy grail of human-computer interaction. We're grateful to Qualisys for one of the most versatile tools to accomplish this and actively supporting and collaborating with researchers like us, but also with institutions such as the Visual Arena at Lindholmen Science Park here in Gothenburg, Sweden. Qualisys is bringing us closer to our vision.
Okay, now we are in some other part in the presentation. I will go through a little bit of accuracy and how we define accuracy with our system. And it could be a bit confusing sometimes. But here is a good explanation what we mean with accuracy and precision. I mean, you can still have good accuracy, but the precision is bad. And you can have good precision, but the accuracy is not that good. But with our system, we have both good accuracy and precision. So that means all our observations are really near the truth and are really close together. And here is some other kind of accuracy that also is a bit unclear sometimes. Global accuracy versus local accuracy. And when you have a global accuracy, it means that you have good accuracy in the whole volume, more or less. And a local accuracy means that if you do a small translation inside the volume, we can detect that with very good precision. But if you move from one side to another side of a volume, that translation will not be detected with that high accuracy. So that is the difference here between local and global accuracy. And in some application, the local one is enough. And in some other application, we definitely need the global ones. So here you can see with the fixed camera, we can achieve the global accuracy. And with the bond calibration, we just achieve the local accuracy. And what we also have a lot of different hardware and software. So we can, as I mentioned in the beginning, we can stream the data in real time with very low latency. And we support a lot of different softwares and APIs to do that. We also have different kind of markers, both active and passive ones. And we have different kind of cameras for different kind of application. And we also have a possibility to synchronize our system, our camera system, with other devices, and also synchronize it with PTP, external time signal and clocks. And in some application, it's very important to be able to do that. Yeah. Our software is the QTM, and QTM can do a lot of things. It can control the hardware. It can synchronize with other devices. It can track markers and visualize it, and also stream the data in real time. And one good thing with our software is that it is a site license. So you can install it on how many machines you want. And here is some of the software that we support to stream into in real time. And MATLAB, LabVIEW, and if you can program, you can use C++ or other languages, and everything is opened. And we have different kind of marker options here. We have different sizes of the active ones and also the passive ones, so it will suit almost all applications. And here is some other things. We also, what you've seen before here in the movie, we had some small drone that was made of crazy flies. And we actually made an active marker deck for that drone, so we can be able to track that on even longer distances. That is very lightweighted. And we also have designed what we call the naked tracker. It's also just a driver with LEDs on that you can use in industrial things to build in these LEDs in the object. And here is the hardware that we have to synchronize both with external equipment and also to synchronize between the camera system. For example, if you want to use the twin system both underwater and above on the same time. And here is our camera models that we have. We have the high-end camera models that is called Arcus. And we have the mid-range camera that is called Micus. And as you can see here, we have different megapixel and different frame rate of the cameras. And it's also possible to run the camera in high-speed mode. That means that we subsample the sensor, so we can double the speed of the frame rate. And we just collect 1/3 of the pixels instead. And here you have the resolution. It's different kind of sensor. Some is really rectangular, and some are more quadratic. And depending on the resolution, what kind of application, we can match the camera type and also the lenses, so it matches your needs there. And the camera has also different range, depending on both the flash and the size, how light sensitive the sensor is. And we also have done a different kind of feature to be able to measure outdoor. What we have is the active marker. We also have a active filtering. And the active filtering take 2 photos, one without the flash and one with the flash. And then we just subtract the images. And that is a feature that helps us to go outdoors. We also have a protect version of Arcus cameras, and it's IP67 protected, so it can handle both rain and wind and so on. We also have a sun filter, and that is a bandpass filter that cuts away almost all the sunlight. And we also have quite a wide temperature range for the camera that we can be used in. Then we have the underwater cameras, and I will come back to that a bit later in the next presentation.
Great, Marcos. Great.
Yeah, we will just load the next underwater presentation here. So if you have any questions, please just interrupt. Yeah, this is the Arcus underwater. It's a new camera that was released end of last year. So today we have 2 versions of the underwater camera. We have this Arcus underwater up to the left, and down to the right we have a Micus underwater camera. That is I will go through in detail more what the Micus is later. So before we had the Ocus underwater camera, and what we have done here with the Arcus, we have done a few improvements from the old versions. We have reduced the size and weight of the camera, and we also changed the material that it was built of. So now it's designed to be able to be mounted permanently underwater for many, many years without any corrosion. And we also improved the flash, so it's able to see on longer distances. And it also spread the light better compared to the Ocus camera. Yeah, that we can skip. Here is the model of the underwater camera that we have today. We have two versions of the Arcus cameras. We have 12 megapixel cameras that can reach really long. And we have A9 camera, it's 9 megapixel, and it's really wide angled. And it's also powerful, so you can also reach quite long. You have a strong flash and a high, many megapixel on the sensor. Then we have this more middle-end camera, it's the Micus camera. And the Micus camera is not that high resolution, it's not so many megapixel, and the flash is not that strong as for the Arcus. So depending on what kind of size of a basin, you can select which kind of camera model. With the Micus models, they are more wide angle, so they are designed for smaller basins. We also designed a new mounting for the camera. Two types, one that you can mount permanent into the concrete, and one that is flexible. Here is a photo of them, and we have the same kind of mount for Arcus and Micus. And here you have one plate if you have the flexible mount. You have one plate that you can attach to the concrete, and then you can just place either a Micus or a Arcus camera onto that mount. And it's very easy to remove the camera and place it back with this kind of mount. So it's just one screw that you need to screw in when you remove or attach the camera again. So here you can see we're using the same mount, and it's just the second part that is a bit different between the Arcus and Micus cameras here. And one big difference between the Arcus and Arcus is that they have changed the way how to adjust the angle of a camera. With the Arcus, we had like a ball joint, and it was a bit tricky to adjust because you can adjust all three rotations in once. Here we have separated them, so you can rotate it in one direction at a time. So that makes it much easier, and you can also lose the screw just a bit, so you have control when you rotate it. And here is just a system overview, how to connect it. We have one cable for each camera here for the underwater case, because and we have a control unit, and each control unit can handle up to 3 cameras. And the control unit you can just DC chain, and the first unit is connected to the computer. And we have also made new underwater markers, and the new markers should be able to stay underwater for longer time. We had a problem from the beginning with the old one, but after a while, the marker itself, the marker tape took in water and was not reflective underwater anymore. So you needed to take up the marker and dry it. But now it can stay for much longer time. And the calibration kit is of course also made of a new marker here. And we have also improved the linearization grid, both for underwater and for above water. And we have a new calibration kit also. So here is the underwater models with the full specification. You can also find all this information in our webpage. So we have 2 Micus models and 2 Arcus models. So if you are interested into knowing all the details, you can just have a look at our homepage there. Thank you. If you have any question, please.
Thank you, Marcus. Do we have any questions from the streaming? No. Okay. Pedro, I think we have a bit of time for you. We will have Pedro come from Poly talking about what they do, and we'll show a movie also from reality. So I hand over to you, Pedro. Thank you.
Eu vou Está lá mostrando. Tá bom.
Bom dia, meu nome é Pedro Melo, eu trabalho no laboratório na Universidade de São Paulo, que utiliza o sistema de câmeras da Qualisys para fazer o rastreamento de modelos de estudos navais, né? O laboratório chama TPN, tanque de prova numérico, mas apesar do nome, nós temos um tanque físico. E esse tanque físico é utilizado normalmente para fazer ensaios de modelos navais, de plataformas de petróleo, navios, e também sistemas underwater. Por conta disso, nós temos também o sistema de câmeras underwater da Qualisys. Normalmente, nós realizamos ensaios de comportamento em ondas, né? E também um sistema de atuadores para impor movimento aos modelos, né? Tanto modelos, por exemplo, de risers dentro da água, como também modelos para levantamento de coeficientes hidrodinâmicos dentro da água, né? E fora da água, as plataformas, como já mencionei, e também alguns outros tipos de navios controlados remotamente, como se fossem os drones que o pessoal aí já apresentou o conceito, né? Então, poderia passar para o vídeo que ilustra diversos... Yes, please. Yes. E pode mutar o som, por favor. A gente vai passar um vídeo mostrando, assim, de forma ilustrativa, diversos ensaios que são realizados, né? E daí, ao longo do vídeo, eu vou explicando como que foi feito o setup no sistema e como que nós utilizamos o sistema de câmeras nesse rastreamento, certo? O nosso laboratório fica na Escola Politécnica da USP e com ele nós temos uma área útil de 14 por 14 metros, né? E 4 metros de profundidade. E nós temos o sistema de gerador de ondas, né? Com absorção ativa de ondas. E utilizando esse sistema, nós conseguimos absorver ativamente as ondas no tanque e realizar ensaios com diferentes direções de onda ao longo do tanque, né? Na imagem do vídeo agora está aparecendo apareceu um vídeo com o sistema sem absorção ativas, né, mostrando como seria se houvesse geração de onda, mas não absorção, e agora mostrando a imagem com absorção ativa de ondas. Então, o sistema tem uma série de sensores em cada um dos batedores de onda que compõem a lateral do tanque e ele absorve as ondas, né? Como ilustração do que o gerador de ondas pode fazer, estamos vendo aí a imagem de uma onda concêntrica, né, que a gente pode concentrar a energia de ondas dentro do tanque de provas de forma a concentrar a energia num ponto específico, né, para finalidade de demonstração. Aí o que seria agora uma onda oblíqua no tanque, né, gerando a 45 graus, mas sem o sistema de absorção ativo ligado, de forma a criar uma onda estacionária, só que bidirecional. Então, nesse caso, duas frentes de onda interagem nas paredes laterais a 45 graus e se somam, formando um padrão na água, né? Esse padrão é a interação de duas ondas estacionárias em duas direções, a 90 graus uma da outra, né? Para outro exemplo do que pode ser feito com esse sistema gerador de ondas, né? Nós temos aí uma onda que a interação entre as ondas forma um desenho na água. Então, no caso aí, vamos formar o desenho da bandeira do Brasil. Isso é uma forma de ilustrar como que funcionam essa questão de ondas transientes para formar figuras na água. Isso é uma forma bem ilustrativa de mostrar o que é capaz de fazer com o sistema gerador de ondas, né? E nas finalidades práticas do laboratório, normalmente a gente aloca no meio do tanque um modelo que vai ser ensaiado, né? E utiliza o sistema da Qualisys para fazer a medição do movimento das embarcações, né? Normalmente pode ser feito com um sistema utilizando 3 ou mais marcadores e 3 ou mais câmeras, de forma a criar um corpo rígido e utilizar essa informação para fazer levantamento do comportamento em ondas, né? Como, por exemplo, nessa imagem dessa plataforma submersível, é possível notar que no deck da plataforma existem vários alvos passivos e o sistema de câmeras que está alocado ali na ponte de instrumentação está fazendo o rastreamento do movimento da plataforma, né? No caso, é uma plataforma semi-submersível. Agora, outro exemplo, que seria um navio plataforma de FPSO adaptado de um casco de navio, né? Que nesse caso o sistema óptico são vários alvos que estão alocados em cima dessa estrutura no convés, de forma a também medir os movimentos, né? Isso para questões de levantamento do comportamento das plataformas, né? Um outro exemplo muito interessante é esse do navio controlado remotamente por rádio, em que o sistema óptico está sendo utilizado para rastrear o movimento dele e, com essa informação, uma malha de controle comanda os propulsores do navio para comandar ele ao redor do tanque. Então, é possível, por exemplo, manter ele estacionado numa posição específica enquanto a gente incide alguma condição ambiental de onda e vento nele, ou então a gente pode comandar o navio para ele executar manobras controladas remotamente com o sistema de câmeras interagindo, né? Esse é somente mais algum exemplo de ensaios de levantamento de impacto em ondas, né, que não utilizou o sistema óptico. Esse daí é um outro bom exemplo que dá para ver os alvos todos alocados em cima do modelo, né, de forma que o movimento da embarcação está sendo rastreado, não só rastreado em 3D, como em 6D, né, que seria os 6 graus de liberdade, que é o movimento dele. Um exemplo aí de ensaio executado no tanque de provas também. Esse para uma finalidade de calibração do sistema, né? Normalmente o ensaio ocorre mais ou menos dessa maneira, então é o típico de execução. Esse é outro exemplo bem interessante, utilizando o sistema de câmeras. A gente podia pausar o vídeo um pouquinho, só para explicar um pouquinho. Nesse caso, é um setup um pouco diferente, é bem interessante, que o modelo maior que está no tanque de provas, né, ele representa uma plataforma de petróleo. E o modelo menor é um barco controlado remotamente, com sistema de propulsores, de forma que ele segue o modelo maior. Ou seja, os dois modelos têm alvos, né, marcadores colados nele, e o sistema de coordenadas do navio pequeno segue o sistema de coordenadas do navio grande. Então, dessa maneira, conforme a plataforma se movimenta em função das ondas, o barco pequeno sempre tenta manter o aproamento relativo, né? Que normalmente é chamado de side-by-side, né? Que seria um aproamento lado a lado, né? Pode despausar, por favor. Então, com o sistema gerador de ondas, a gente gera uma onda de um sentido no tanque de provas e depois pode modificar o sentido da onda para verificar diferentes incidências de onda, né? E, novamente, o barco pequeno está sendo controlado remotamente. O sistema de câmeras está enviando a informação em real time do movimento das embarcações e isso vai para um computador que tem uma malha de controle que aciona um sistema via rádio para controlar o movimento do barco pequeno. Então, ele fica sendo controlado remotamente pelo sistema de câmeras. Esse é outro exemplo que é possível também medir os movimentos de plataformas de movimento que nós temos no laboratório com sistema óptico e realizar ensaios com líquido dentro de um tanque, emulando o tanque interno de um navio. Daí, normalmente, isso é utilizado no laboratório para fazer validação de sistema de modelagem numérica, que é executado em cluster computacional. Esse é um outro bom exemplo do sistema de câmeras de tracking. Eu pediria para pausar um pouquinho só nesse, só para explicar. Pode pausar. Yes, yes. Yes, it's fine. Very good. Nesse caso, foi um sistema que a gente utilizou o sistema Twin System do sistema de câmeras, porque é possível ver ali num suporte horizontal na imagem que a gente usou 4 câmeras, né, de rastreamento, calibradas num computador para fazer a medição do movimento de um mangote criogênico flutuando na linha d'água. Só que as pontas do mangote eles saem para fora d'água e existem uma série de alvos reflexivos no mangote de forma a gente poder medir o movimento que ele está tendo fora d'água. Só que, eventualmente, o que a gente queria determinar nesse experimento era que esse mangote, eventualmente, no ensaio em ondas, poderia sair para fora d'água. E, nesse caso, esse sistema de câmeras iria fazer o rastreamento dele. Agora, dentro d'água, o que não dá para ser visto ali na imagem, que aquele suporte continua para dentro d'água e lá dentro existem 4 câmeras montadas da mesma forma que as câmeras aéreas, fazendo também o rastreamento da parte imersa do mangote. Então, enquanto ele faz uma curvatura dentro d'água, o sistema está também dentro d'água fazendo a medição dele. E usando o sistema Twin, o que nós fizemos nesse experimento foi fazer uma calibração do sistema aéreo, do sistema underwater, e depois fazer a calibração do sistema Twin, interagindo os dois sistemas, criando um único sistema de coordenadas. Então, com isso, a gente teve um único sistema de coordenadas definido numa certa posição. Eu não me lembro agora se era na parte fora d'água ou dentro d'água, mas esse mesmo sistema de coordenadas valia tanto para as medições fora d'água quanto a parte imersa. Então, dessa forma, a gente conseguiu fazer uma medição de toda a movimentação desse mangote quando ele sai para fora d'água e quando ele está imerso. Um ensaio bem interessante. Então, utilizando o gerador de ondas, nesse experimento, por exemplo, a gente gerou ondas de diferentes direções e mediu com o sistema qual que seria a movimentação dele. Daí, de novo, essas informações que foram obtidas serviu para calibrar a modelagem numérica para depois fazer diversas outras simulações em cluster computacional. Pode liberar o vídeo. Ok, thank you. Esse é o exemplo aí do sistema, inclusive utilizando os dois sistemas de câmeras, né? Esse aí, no caso, é um outro experimento que nós realizamos para comparação de modelagem numérica, né? Isso, no caso, aí em CFD, né, em Computational Fluid Dynamics, para calibrar a modelagem numérica de fenômenos de embarque de água em plataformas. Assim, basicamente, e esse daí é o último experimento que aparece, que também utilizou o sistema de câmeras para fazer a medição de 2 embarcações simultaneamente. Então, cada uma delas tinha um sistema de coordenadas local e, eventualmente, nós podemos também utilizar esses 2 sistemas de coordenadas locais, ou então criar um sistema de coordenadas único e referenciar cada uma das embarcações separadamente. E essa informação pode ser enviada em tempo real para outro computador para fazer controle de posicionamento. Basicamente, esses os experimentos que eu tinha para ilustrar para vocês.
Oi, Pedro. Bom dia. Obrigado por ter vindo aí pela explicação.
Disponho.
Agora, isso não foi combinado, viu? A entrevista aqui com você.
Ah, entendi.
Não, na verdade, a gente já utiliza, né? Vocês utilizam há muito tempo o sistema, né?
Perfeito,
Eu lembro
perfeito.
isso antes da parte do TPN utilizar. Eu lembro que tinha um sistema bem antigo no IPT, né? Que era o Hamamatsu, é um sistema
Sim, sim.
japonês, mas trazia, até com o professor Umeda, trazia muitas complicações para calibração, né?
Certo.
Assim, há quanto tempo você está usando o sistema já, da Qualisys?
Há mais de 10 anos, eu acho que nós começamos desde que inaugurou o prédio do laboratório que tem o tanque de provas em 2009.
Em construção ainda, né?
Foi.
Dentro da sua experiência, assim, eu sempre falo com vocês, né? Mas a parte de manutenção da câmera é mínima. Acho que a que tem um pouco mais de cuidado são as câmeras underwater, né?
Exatamente.
Mas as aéreas, assim, o que facilitou a vida de vocês da parte quando você está utilizando o sistema, né? Se não tivesse esse sistema, teria outra forma de fazer? Assim, o que você vê de facilidade em uso do sistema?
A facilidade é o seguinte, até como eu estava explicando nessa questão aí de fazer ensaios de posicionamento dinâmico de embarcações, ou também acrescentando o ensaio também de manobras de embarcações que a gente chegou a fazer com o nosso sistema de câmeras, mas em outro laboratório ao lado do TPN, né, que tem uma bacia de água bem maior, que é o CTH, né? A gente chegou a utilizar os sistemas de câmeras nesse outro laboratório para cobrir uma região bem grande do tanque. Essa imagem que a gente está vendo aí ilustra bem isso. Normalmente a gente pode fazer um ensaio focado no modelo, em que daí a gente conseguiria medir de forma mais precisa a movimentação para ensaio de comportamento em ondas, né, com as câmeras bem próximas, ou então colocar as câmeras ao redor da bacia. Então, por exemplo, esse caso que eu citei desse outro laboratório que nós realizamos ensaio, a gente utilizou as câmeras ao redor de uma bacia que tinha, não lembro se era aproximadamente 20 metros. E o sistema conseguiu medir com uma qualidade boa, assim, da mesma forma como o Marcos explicou na apresentação, com uma precisão um pouco maior de 1 milímetro, né? Só que isso já era suficiente para realizar esses ensaios de manobra que tem uma dimensão muito maior, né? Então, isso deu uma flexibilidade muito boa, porque a gente já chegou a fazer ensaios bem mínimos, em que a gente colocou as 4 câmeras focando um volume bem pequeno, né, uma área de meio metro, por exemplo, e daí, nesse caso, utilizamos o kit de calibração menor, e daí a gente conseguiu uma precisão, não diria que chega a micron, mas ele chega a décimo de milímetro. Então, chegou a esse ponto de conseguir, com uma medição bem focalizada, e um outro extremo de fazer numa bacia. Então, essa foi a grande facilidade do sistema, por poder alocar as câmeras e escolher a resolução que a gente precisava e cobrir o volume que a gente precisava. Foi bem interessante nesse sentido.
Flexibilidade nas operações, dentro das operações de vocês, né? E com relação à integração, né? A gente sabe que o sistema faz o tracking, né, os 6 graus de liberdade, mas você obtém outros sinais, né? Você trabalha com outros sinais dentro de um setup, né? Como que é essa experiência junto com o Qualisys, né? O que você pode falar que, assim, o Qualisys ele aceita outras sincronizações, né?
Exatamente. A gente chegou a fazer experimentos, muitos desses como aparece aí na imagem, que a gente tem 3 navios DPs, em que a gente exporta 3 corpos rígidos para um sistema de controle externo, que rodava em MATLAB, no caso. Então, daí a gente fez uma rotina de integração que usa o protocolo padrão da Qualisys de Real-Time Protocol, de exportar essas informações. E como tem a documentação disso, o pessoal fez uma versão inicial que estava em LabVIEW, por exemplo, que conseguia já comunicar diretamente. E depois foi feita uma outra versão em JavaScript.
Em Java?
Em Java. E depois foi feita uma outra versão em C++, diretamente num sistema em real-time no Linux, utilizando um kernel real-time. Então, a gente já chegou a fazer pelo menos 3 tipos de integrações diferentes, né? E mais alguns meses a gente vai realizar também uma nova em LabVIEW, novamente.
LabVIEW. Tem todas essas facilidades, né? Na verdade, vocês sim, eu acho que a parte mais importante do trabalho de vocês são a acurácia dos dados, a precisão dos dados, e não se preocupar tanto com o processo, com a relação de setup, porque o setup das câmeras calibrado, né? Apesar que eles mostraram o tanque de vocês relativamente grande, né? Mas não tão grande quanto os outros que a gente conhece. Né?
E o detalhe, né, importante sobre experimentos em tanque de prova é que, como a gente está fazendo tudo em escala reduzida, a precisão do equipamento precisa estar dentro de um range inframilímetro, vamos dizer assim, porque no caso, quando a gente for enviar, passar essas informações para a escala real, a precisão é importante, porque senão no mundo real, passando, por exemplo, alguns ensaios que a gente chegou a fazer em escala 1 para 110, 1 para 120, normalmente 1 para 80, 1 para 90, é muito importante ter uma boa precisão na medição para depois passar para a escala real.
Tá. Assim, às vezes quem está assistindo talvez não tenha conhecimento, né? O porquê dessa mensuração seria por conta de segurança, questão de construção de engenharia, ou por que você faz essa análise toda dentro do laboratório, você falou em escala, né? Por que isso é importante quando você vai se construir ou quando você vai levar para a vida real, né? Para a operação real?
Exato, tem essa questão aí por conta de ser... assim, a atividade do laboratório é acadêmica e pesquisa e desenvolvimento. Então, a necessidade de ter uma boa precisão nas coletas de informações que a gente está fazendo vai ser essencial para depois a gente poder fazer o transporte para uma modelagem numérica, para fazer a extrapolação para a escala real, para poder ter uma boa acurácia nos resultados. Isso que é importante ter em mente em laboratório. Assim como, por exemplo, todo o restante da instrumentação que a gente utiliza, né? Medir bem a onda, medir bem a força, medir bem os movimentos. Isso, basicamente, são os pontos essenciais.
Isso é robustez que te dá garantia em qualquer outra. A pesquisa é fundamental nesse caso para você extrapolar para a vida. Você poderia falar um pouco desse setup?
Assim, esse daí especificamente, né, passou num vídeo lá um ensaio de posicionamento dinâmico de navio, que no caso era um navio menorzinho que está aparecendo aí na imagem. Lá nós utilizamos, por exemplo, no sistema local de coordenadas só daquele navio, mantendo o sistema estacionário. Mas nesse caso, por exemplo, a gente colocou 3 câmeras ao redor do tanque, né? Tem uma que está à direita na imagem, uma que está próximo de onde foi tirada a foto, e outro no lado oposto à esquerda, de forma a cobrir essa região bem maior do ambiente. E daí, nesse caso, por exemplo, a gente utilizou todos os marcadores passivos,
Perfeito.
Um marcador um pouquinho maior, né, para conseguir ser visualizado numa distância maior, mas mesmo com 3 câmeras, com a precisão em volta de 1 milímetro, 1,5 milímetro, nesse caso, já é possível fazer o controle dos navios por conta do sistema posicionamento dinâmico, tem uma dinâmica muito lenta, né? Os navios não têm, mesmo em escala reduzida, eles não são tão rápidos, né? Como um drone, por exemplo.
Uhum.
Então, nesse caso, a gente admite que pode ter uma medição com precisão de 1,5 milímetro, coisas do gênero. E daí, no caso, a gente está controlando 3 navios, mantendo eles estacionários, né, no tanque, mas também a gente poderia enviar comandos para o sistema para fazer manobras. Então, daí, nesse caso, eles poderiam fazer manobras no tanque de prova.
Então, funcionaria quase que um sistema de automação. Você poderia pré-setar um espaço delimitado dele, onde que, caso ele extrapolasse, o motor poderia atuar de alguma forma para ele manter aquela posição. Basicamente isso.
Exatamente. Daí, no caso, houve já com o sistema, fazendo uso do sistema, e esses navios com posicionamento dinâmico, pelo menos 2 trabalhos de doutorados que foram criados no laboratório, utilizando técnicas diferentes de controle entre as embarcações. Né?
Maravilha, maravilha.
A parte acadêmica, isso é bem interessante.
Maravilha. Obrigado pela explicação. Martin,
Yes.
I interviewed some questions about because there's some people watching and they are interested in how to explore the system. It's I cannot say unlimited, but there's a lot to do with the system with Qualisys because automation, robotics, marine, and
Yeah, what I can say, there are no limits actually. Of course, there are limits, but from what we do today, we are in so many different applications. So I used to say, when I get that question, I say, we can measure on any object that you want to see. We can put, as long as we can put a marker onto the object, and that the environment is somewhat possible to measure in. I would say we can do most applications.
Yeah. And then with high accuracy.
Yes.
High
so
accuracy.
And that's why we it's always tricky to when you have a streaming and an audience, you don't know the different applications they have. So it's tricky for us to go in and show everything. It has to be something general and so on. But of course, if we now have people here on the streaming that have a certain interest for their application, we are all interested here from our side to maybe do a visit or to discuss that further to see what can be done. Of course, that's the way we work.
One important thing, it's SDK. SDK. That's we can. It's inherent of the system that we can do any application for automation, for any kind of process that you want to control with high precision.
Absolutely. And as an example to that, I can say that if we take ABB, which is a multinational company, ABB uses our cameras in a way that they just buy the cameras and take the signal straight into their own software, which they have produced. And they are used actually in the harbor for container handling then. So they have an anti-sway system for the trucks that picks the containers, and when the container starts to sway, actually the camera sees down and it stops the movement. So it's their own system. We just deliver the cameras. They have made their system. So there are all types of things that can be done with the cameras.
Yes, a similar application that people in Brazil are trying to develop. It's to loading the ship and monitoring real time. But outdoors. That it's similar than ABB.
It is similar, and this is outdoor for container handling. So there is a similarities because you want to see in the cargo handling in a ship, you're quite long distance as well. So it's a matter of exploring what kind of levels you can use the cameras. Is it one camera or there several cameras? It all depends on the situation and what can be done. But it's a similar one that ABB is doing today.
Yes. Also, there's automobilistic or other. For example, the wind tunnel and the ITA in Brazil, they are still working. We see at Embraer also some applications that we in the tunnel that they can explore for any kind of.
Yeah, I used to say we work with anything from animals to NASA, because actually NASA uses our things as well, and so so from Earth to Moon, but that's not how it is, of course. But it's a wide variety, and sometimes we don't even know for what the purpose is, and because they are not allowed to tell us, so we sign NDAs or whatever that is needed to do these things. And that is also important to understand, that if a company is coming to us and saying, we are interested in working with you and your cameras, but it's actually a lot of secrets in this, then we sign the NDA and we do those things together with these customers, because we have a development department that actually, if anyone is coming to me saying this, I say, okay, now we better start this from the beginning, sit down with the development to see what would you like to do to actually see if our camera can match what you're interested to get out of it. Yeah.
Great, fantastic.
Yeah.
Okay.
So thank you, Pedro. Fantastic. Good to have some something from real life as well to show here. We have a plan now to do a demo with drones here. Marcus, are we in a position to start the drone demo? Ending this today, we are slightly ahead of schedule, but we will do a little bit of a demo with drones flying and how that is connected into our QTM system to see if we can show those things for you. And then we come back here and see if you have any questions. And I point out again, if you have any questions for us, feel free to put that in the chat, and we'll try to answer them. And also, if you find anything now here very interesting to continue and discussing, just do not hesitate coming back to us here at Carci with Orlando or to us, and we will be glad to answer the questions or even pay you a visit. Okay?
Ok, I'll tell in português the people. Caso qualquer participante dentro do streaming está interessado em conhecer mais, ver a aplicação em tempo real, ou ver mais detalhes, entre em contato conosco, que a gente tem algumas câmeras aqui justamente para avaliar isso. Vocês, a gente sabe que é importante ter contato com o sistema para ter a ideia de quanto é poderosa a ferramenta para explorar tanto na parte de pesquisa quanto na parte industrial. Então, só tendo contato mesmo, a gente está fazendo esse evento justamente para promover esse conhecimento. E todo esse conhecimento, acho que facilita, é um projeto de melhoria de país, né? A parte de tecnologia a gente não consegue produzir aqui ainda, mas por isso que a gente tem essa parceria para desenvolver dentro de centros tecnológicos importantes, centros de engenharia e de pesquisa, para a gente ter um crescimento dentro do conhecimento técnico, né? Isso é importante para a visão de estratégia de país, né? Ready? Now this is the drone time. Take care, this drone is coming.
Okay, yeah. Okay, first of all here, I just want to show a little bit from QTM, our software here. So what we will do is, we will place the drone here in the middle of the volume. And you can see the drone here with the own coordinate system in the volume. And you can also see each marker. Now we have 4 markers in the drone. And you can see the coordinates for all of them. And you can also see the 6-off body, X, Y, and Z, and the rotation angles. So what we will do here, we will stream this data into Unreal. So we will show you how the real-time feedback from our software is working. So that is the purpose of this demo here. We will move this cable to your computer. Yeah. But QTM won't be showing anymore? No. Or why not plug it to another TV? No, we are not allowed to do that because we cannot stream it. But later I can change that. So now we will connect to the Unity computer here instead, and the QTM will just stream the data here. Unfortunately, we are not able to show both screens at the same time here.
Agora vocês vão acompanhar a parte de aplicação do o drone em tempo real, funcionando com o Unity, dentro de uma engine, é uma engine de game, na verdade esse vai ser Unreal, né? É outra engine, onde isso pode ser desenvolvido várias outras aplicações dentro da engine. Ok. We'll restart. A gente vai reiniciar o computador aqui só para sincronizar o sistema. Então, Jean está fazendo o setup, ligando o drone. Só lembrando, toda essa parte de aplicação, então vocês podem estar sincronizando dentro do sistema, mandando os dados via MATLAB, LabVIEW, ou mesmo essas integrações com a engines, né, de Unreal. É uma engine de game, mas serve para várias outras aplicações, até na parte industrial também, porque ela pode ser programada em C++, tem outras programações, linguagens que podem ser utilizadas. O pessoal usa mais para a parte de game, Unity e Unreal. Então, isso mostra até um pouco perto da aplicação que o Pedro comentou, das limitações, né? A gente tem um volume, temos algumas câmeras aqui trabalhando. E isso faz com que as câmeras possam capturar em tempo real o movimento, tudo que está dentro desse volume, a gente consegue ler todos os dados, né, de posição, velocidade, aceleração e a rotação nos 3 eixos. Isso, em termos de aplicações na área industrial ou mesmo na parte de pesquisa, é fantástico para dar robustez na aplicação. A parte de acurácia chega a 0,03 milímetros de precisão. Então, a gente consegue mensurar isso em tempo real em várias situações. A gente está usando um drone da DJI, mas como vocês viram na aplicação dentro da Michigan, lá nos Estados Unidos, era um drone outdoor. Essas câmeras que estão aqui não são outdoor, elas são indoor, mas tem uma precisão, varia de 4 megapixels até as outras câmeras variam até 12 megapixels, né? 26 megapixels também. Ok. A gente vai só restartar a aplicação para sincronizar, porque estava em outro computador. Só a gente já volta em 3 minutos aí, 5 minutos a gente já volta. Todo mundo pronto? Jean, are you ready? Are you ready? Are you ready for love? Are you ready?
What is very glasses you have now? You have two different.
Ready? Okay. We are live.
The arcade game.
It's yours. Oh, yeah.
Wait, no, but Mark is gonna give me a hand with the microphone because we don't have.
Okay, okay, let's do it.
Hello again, everybody. We're gonna do a quick demo
Tamo
of
vivo?
a drone game called Virtual Racer that we are working on internally at Qualisys. This is a mock-up. It's not a real video game. That's not gonna be outside in the arcade games. Well, maybe someday, we don't know.
But it's
yes, thanks.
sorry to interrupt you.
Yes.
But it's this application that we'll show now.
Yes.
It's very similar that Pedro was talking before. It's like the limitation because we have some limitations on the wall.
Yes.
Right.
Yes.
That you will after that the drone cannot pass.
Yes.
Yes.
So we have to adjust the play area inside the game to the mocap volume, obviously, that we have here,
Yes.
with a bit of a margin, so that when the player is close to the wall, there's no an actual physical wall in the room, but there's a few centimeters, so people have time to stop.
But if
we'll see, maybe they don't have time to stop, and that's also...
We can say that the life is like a video game.
Yeah, exactly.
The real life is like a video game. We are
So
trying to do some maybe industrial here, but it's like a game. Yeah?
exactly. So the idea of this application was to play a game and flying a drone inside a video game, but with real drone physics.
Right.
Because the drone that you will see in the video game is not controlled inside Unreal Engine, but it's this drone here that's driving the position of the drone in the game. So
Perfect.
if you release the forward button, your drone is not going to stop straight away. It will, of course, follow the physics of this drone, which adds a little bit to the, the difficulty of the game. And this also to showcase how accurate we can track something in our volume.
Nice.
We'll see how well it works today. We have a little bit of problem with the setup, but we can try it. Yes?
Okay.
So
Perfect.
I'll just
We are
start the
ready.
game. I think this one is
Do you want to? Any help? Oh, okay, it's connecting, almost there. Ok. Ele está reconectando o drone aqui, que eu fiquei enchendo a paciência dele.
screen, but this is the, do I have a camera here? I don't, is this the main camera, this one? Yes. This is the main camera, okay. So this is the view from the drone. I don't know if you will see much. This is the view from the camera. So the drone, the real drone is connected to this telephone, to this mobile phone here.
Okay.
And the drone is controlled directly with a controller, a regular controller. And so now the game is in wait state. It's waiting for the drone to take off. So let me take off, start the drone. And so now the game is ready to go. And I'm going to try and pilot it and not crash it. So the aim of the game is simply to collect stars that are being spawned in the volume whilst avoiding those red obstacles. So it's a bit confusing at first to start playing it, but you need to play with the, you need to rely on the screen that you're looking at and trust the tracking of QTM. So I'm going to try and run. We have really a lot of lagging now. Okay, so
I'm a star.
Okay.
I'm a star. Oh,
so now the countdown has started. After you've picked up one star, the countdown has started, and you continue playing it. Can I get in the second one? Yeah. So that's an application. That's a very simple application. of tracking an object in a volume. We could obviously have more than one drone. We can have a drone battle because we can track more than one object at the same time using QTM. So we could have 2 or 3 drones at the same time. Obviously, we have some collision issues with this kind of things, but it's quite possible to do. You can develop a lot of different applications and games like this quite quickly using any real-time game engine such as Unity or Unreal Engine.
Perfect.
And this is working not bad actually. But okay, I got more. I see the score. I'm on 7, then I'm almost done. So what happens if I go inside a red cube? So, oops. So if you leave the mocap volume and you come back, okay, now it got flipped, but I'll come back in. I'm gonna try and say hello to those lovely people behind here that've been helping us the whole day. Try and come back. I hope we're not flipped anymore. Okay, here we are. We're back here. So if you go inside a volume as you go, you get this kind of distortion effect like you would have in a proper arcade game to try and mess up with the player.
There's some turbulence.
Yeah, some sort of, yeah. Did I not put I know I had something inside of it saying to stay away from it.
Oh, nice.
And so the tracking works really well, and the great thing is that you can get outside of the volume and come back in it, and the drone keeps being tracked. And then, of course, this is just a mock-up of a game, so I don't have the whole thing. But the next version will have, when you get to 0, you can insert your name, put your name, and we'll have a leaderboard. And that's a fun application to showcase how accurate we track something with the game. So
Perfect.
if anybody wants to try it, please. Do you want to give it a go?
Do you want to try it?
Let's try it.
Jose,
I did 9 points. Come on.
Jose, come on. Pedro, do you want to try? Pedro, you are used to drive a ship?
The best will be, I'm going to explain the control quickly. I don't know, have you flown a drone before?
No, one time.
Okay, great. How many times you crashed it?
All the times.
Okay, good.
Sometimes.
We have 2 more. Okay. We knew you were coming. Okay. Anyway, this left joystick up goes up, down goes down. To the left rotates.
Okay.
This one thrust forward, thrust backward. This one strafe right, strafe late. Okay. One thing, it's best for you to play properly, either in front of that one or in front of that one.
Okay.
If you really get lost, you can look at the drone. The front is the LED screen. Okay, so if you're a little bit lost, you can simply stop pushing buttons, rotate until you see the LED screen going in the direction that you want. Yeah?
Too complicated to me.
So the timer starts after you've picked up your first star. So there's no stress to fly as fast as... After that, you can. Are we ready to go? Okay. Then let's start it. I'm going to make you take off. No. You can see on the screen. 3, 2, 1. And now you can go. Doing great. Almost there, a bit lower. Good. Now let's start. The timer has started.
Update.
So don't go too low because we lost it. No, you're good. Yeah, you may, if you get too close to the walls due to our setup today, you might lose it a little bit. Some tracking. I'll stay outside of the volume.
It's too complicated.
No, it's not. He's gonna get it. It takes a bit of time. I have flown this a lot. There you go. Yeah, the star right there, a bit to your right, straight on, and then there. straightforward. You have plenty of stars now. You have a new star popping in the volume every 5 seconds to make things easier. Good. 3 points. Doing great.
I believe that Pedro used to play at
Now,
home.
look. There was a double
Video
spawn
game.
in that spot, so you're probably going to score. Yeah. That was an interesting one here. Rotate. Are you doing a back?
Look,
Careful,
look.
careful, careful.
Look
That's
at
normal.
that.
That's not your fault. This treadmill shouldn't be in the volume. You're back. You flipped. So when you flipped, I don't know what's happening here. I'll tell you what to do. Rotate that way. Drive forward. Or drive that way. Okay, we're low battery now. Sorry. The battery is low.
That's over. Thank you. Thank you, Pedro.
Well done.
Nice. So nice, Jean.
So we have some limitation today due to the setup we have here. But I designed this one in the office at Qualisys in Gothenburg, and we had 10 Arcus and a bit bigger volume, and the tracking was perfect. So you don't have those little jitter, and you can go faster. And the drone was has 2 speed actually. So this was the slow mode, and then you can go fast. And that's when you start having some fun because you can use the drift and you know what I mean. So yeah, that's but thanks a lot.
Okay, thank you, Jean. Thank you.
Thank you, Jean-Marc. I think that's good.
Yeah.
It's a little bit of showing what we have a little bit of fun in the office too, and show how we can work with controlled loops. So that's interesting. I think we have done what we can do today. Orlando.
Yes, it's
It's been an honor
just an
having-
introduction what Qualisys can supply to Brazil in different solutions.
Yes, and as I said before, it's difficult to know each and everyone that is listening, looking, and what kind of applications you have. But we will be happy to talk to them, Orlando, and see what we can do. From our side, it's been an honor to be here. Thank you very much for watching and being here. And that's all from us, I think.
Yes.
Yes.
Thank you so much. Thank you, Marty. Thank you, Marcos. Thank you, Jean.
Yeah.
Thank you, everybody, for
Thanks
for
for
watching,
coming.
and thank you for time.
Yeah. Thank you, and bye-bye.
Fechou.
It's not a game, it's a rich thing. It's not a game, it's a rich thing.
like this, make it pop like this, make it not like